And with our reciprocal functions, we have the cosecant of theta is equal to, instead of your opposite over your hypotenuse, it's going to be hypotenuse over opposite. So I have the square root of 34 over negative 5, which if I just simplify that down into something that's easier to look at, this will be negative square root of 34 over 5. The same thing with secant of theta. I'm going to have hypotenuse over adjacent. So this is going to be the square root of 34 over negative 3. So this is going to be negative square root of 34 over 3. And then for my cotangent of theta, then this is going to be adjacent over opposite instead of opposite over adjacent. So this is going to be negative 3 over negative 5. And again, two negatives make a positive, so I have 3/5. Okay. And then once we know these relationships, then we can also find the angle measure of theta. And so to do that, I can take any one of these trig functions, and it doesn't matter which one you take, and you're going to take the inverse of that trig function. So if I just take I'll take tangent since it's the easier one to work with in the calculator. If I take the inverse tangent of 5 over 3, then that will give me the value of my angle theta here that lives on my x-axis. Okay, now there is a little shortcut rule for you to remember where things are positive and where things are negative in the coordinate plane. And so your little kind of trick for remembering is if I have the coordinate plane here, and I know now that my quadrants I was reminded that my quadrants are 1, 2, 3, and 4. Well, your trig functions are either going to be positive or negative in each of these quadrants. And so what I know is that all of my trig functions are positive. Sine, cosine, and tangent are all positive in the first quadrant. I know that sine is positive in the second quadrant. I know that tangent is positive in the third quadrant. And I know that cosine is positive in the fourth quadrant. And so to help you remember that, if you just remember A, S, T, C in the same direction as your quadrants go, in that counterclockwise direction, then you remember it as A, smart, trig, class. Okay, so another example of what we would use this for. If you are given that theta is equal to negative 2/3, or sorry, tangent of theta is equal to negative 2/3. And you were told that the cosine of theta is greater than 0. Name the quadrant where angle theta lies. So you're talking about the terminal side of theta. So if my tangent is negative, that means I can't be in the third quadrant because tangent is positive in the third quadrant. And if my cosine is positive, greater than 0 means positive. So cosine is positive, tangent is negative. then that can only occur, cosine can only be positive in two places, either in the first quadrant or the fourth quadrant. But tangent is positive in the first quadrant, so that means we have to be in quadrant 4. Okay, and then the last thing we'll kind of touch on a little bit is we'll do a few examples of finding reference angles. So we have find the reference angle. So if I tell you to find the reference angle of theta equals 40 degrees. Well, if you start with an acute angle, then your reference angle is going to be the same angle. So your reference angle is 40 degrees. Because if I graph this and I look at it in the plane, 40 degrees is going to be here. Well, the angle that completes the rotation and is acute to the x-axis has to be that same angle. So if I start acute, then my reference angle is acute, and it's the same thing. If I tell you that theta is 170 degrees, well, then your reference angle is going to be 10. Because using the same quadrant, if I have 170 degrees, that means I'm going to be here. And I need this angle that completes my rotation to the x-axis. And this angle is going to be 10 degrees. Similarly, if I have theta is equal to 230 degrees. Well, when I draw this in the coordinate plane, 230 degrees is greater than 180, but not quite 270. So I'm going to be here somewhere. Well, my reference angle is going to be this angle that brings me back to the x-axis. It's this angle theta that lives inside here. Or we won't call it theta since I called that one theta. So we'll call it gamma. Okay, so if we're looking for this angle, that means I'm going to subtract 180 from 230, and that will give me this reference angle that brings me backwards because I have to travel backwards a certain angle in order to get back to the 180 degree mark. So when I subtract 180 degrees from that, this is going to give me a reference angle of 50 degrees. And then let's say I'm moving in the negative direction and I have theta is equal to negative 300, for example. Well, then when I graph this in the coordinate plane here, negative 300 is going to move in the clockwise direction. So I'm going to be here. Well, my reference angle is going to be the angle that brings me to the x-axis. So this reference angle is going to be 60 degrees because I have to travel 60 degrees more to get back to the x-axis and still be acute. I could go back the other way, but that wouldn't be a reference angle because it's not acute. It has to be less than 90 degrees.